Hi everybody, my name is John O'Reilly. I'm a software engineer at Neat, and the plan for today is to sort of demonstrate the building out of a basic Android and iOS app that uses the same shared Kotlin Multiplatform non-UI code and uses Jetpack Compose for the UI on Android and SwiftUI on iOS, using basically declarative UI frameworks that are sort of being developed at the moment, exist already or in the process of being developed, I guess, in the case of Compose. And I want to show, hopefully, that when combined together, that it's a very compelling combination together. So the plan for today, I'm going to spend 3 or 4 minutes maybe just going through some basic slides just to give some context, just a bit of background, and then we'll spend the rest of the remaining part of the talk actually building out the code. But I wanted to start with just maybe some level set. I'm not too sure. I know a lot of folks here are probably Android developers. I'm not too sure what the exposure is to Kotlin Multiplatform, but at least to sort of level set a little bit. This is a definition from, or a quote rather, from Kevin Galligan from TouchLab. If you have followed Kotlin Multiplatform at all, you're probably very familiar with Kevin and the work that he and TouchLab have been doing, so pioneers in this space. But there's a couple of key things here just to highlight. The first thing is this optionality. What Kotlin Multiplatform offers is the ability to sort of use it for as little or as much of the code as you want. And typically the advice is to start off small, use it for maybe some data model, some remote API endpoint, interaction, so forth, and build up from that. And the other thing, as I sort of will probably mention a couple of times, we're focusing here on non-UI logic. So obviously in this example here, we're using Kotlin Multiplatform for non-UI shared logic and using obviously declarative UI frameworks then for the UI. So these are the range of platforms currently supported by Kotlin Multiplatform. We're talking obviously today about Android and iOS. The repo that today's talk is based on also has implementations for watchOS, macOS, JVM, web, and as of quite recently, there's a branch now for Jetpack Compose for desktop as well. So just to briefly mention, again, if you have been following Kotlin Multiplatform, you may have seen in the last few months the launch of Kotlin Multiplatform Mobile. Just to explain, I guess this is sort of, to a large extent, sort of a rebranding from JetBrains in terms of just really focusing in on the sort of, probably the key use case for Kotlin Multiplatform is obviously sharing code between Android and iOS. And along with sort of updated documentation and guidance, there's also a really nice Android Studio plugin you can use now to create a new Kotlin Multiplatform project and to launch and run and debug Android and iOS apps from Android Studio. So I don't know if folks, how familiar people are with Declarative UI, and some folks may have watched Jorge's talk just before this. But again, just at a very high level, when we talk about Compose or SwiftUI as declarative UI frameworks, people typically talk about the what versus the how. In a declarative UI framework, you describe or you declare what your UI will look like in a particular state. And state is important in this context. Any change in state would be reflected automatically in the UI through sort of an optimized, in the world of Jetpack Compose, you'll hear people talk about recomposition. I think Jorge talks about smart recomposition that it's able to do in terms of understanding from its state change what part of the UI needs to be re-rendered. And you're just left really to, and we'll see an example, obviously, as we're building this out, of if you haven't seen it before, what declarative UI looks like or what Compose looks like and SwiftUI. So just a bit of background. Jetpack Compose was announced at Google I/O in 2019. It's an alpha release right now. It's available in Canary versions of Android Studio. SwiftUI was actually announced a couple of weeks after that at WWDC. It was at a much more advanced stage of development. It was available for download in an Xcode beta that evening. That's sort of what got me started down this path a little bit. And it's described as sort of allowing building of user interfaces across all Apple platforms. And it's kind of an interesting, actually, maybe in the Kotlin world, obviously we talk about Kotlin Multiplatform, but there's something called SwiftUI platform. If you're an iOS developer, you're probably familiar with this idea of having a single code base, SwiftUI code base, to target the UI across all the Apple products. And that's a sort of good segue to, this is sort of, with the announcement of Jetpack Compose for desktop, I was trying to sort of put together something that sort of captured, I guess, the evolving ecosystem that was kind of, emerging for UI development, and particularly with the sort of focus now, I guess, or the convergence, I guess, on declarative UI framework approaches. I mean, we have SwiftUI, as I mentioned, as a multi-platform solution across Apple products. We sort of had Compose for Android, and now we see Compose for desktop, targeting Windows, Linux, and macOS as well. And actually, I've left out actually web here, even since I put this together. I think there's some discussion about, I think Compose for web is going to be available as well. But even if you don't use Compose, for example, the likes of React on a web is also sort of a declarative UI framework, and it's probably seen by many as sort of the inspiration for Compose. And of course, then underlying this, we have the idea that we can use the same shared Kotlin, I'm overemphasizing this, but Kotlin Multiplatform non-UI code where we can share across all those platforms. It's a very powerful capability. So this is the repo that today's talk is going to be based on. It was designed sort of, when I was putting it together, something I would describe as sort of optimally minimal. And I'll probably overuse basic and minimal in today's talk, but the idea was that it was small enough to really sort of be able to see at a glance, really, what the key moving parts of the Kotlin multi-platform project were, and how they were tied together. But at the same time, not be trivial. I mean, we still make a request to remote API endpoint. We still store data locally in the database. And as well as that, as I mentioned, it covers a range of platforms as well. So it demonstrates sort of at a very basic level, at least, this capability we have to run shared Kotlin code across this wide range of platforms that we have available today. And again, if you've seen the Kotlin Multiplatform docs, there's a link to this project as well from it. So again, just briefly, again, in line with the project, this is sort of, again, that word, minimal endpoint that we're going to be hitting. The repo actually, if you do look at, if you haven't seen it before, or if you want to try it later, the repository that's in GitHub also has another endpoint for the position of the International Space Station. But the repo we're going to use, or the endpoint we're going to use today is simply just returns the list of people in space basically right now, astronauts in space at any particular time. And just kind of a shout out to NASA and SpaceX for launching 4 new astronauts yesterday, I guess, which has sort of made our UI going to be a little bit less bare than it would have up to now. There was 3 astronauts before yesterday, so thanks guys. And lastly, I suppose before we go into code, just a quick overview, I suppose, of high-level architecture. Again, below the line we see obviously the shared code. We have a class representing our interaction with the remote API endpoint, and we're using JetBrains' Ktor library for that. If you're familiar from the Android world for something like retrofit, this is something that Ktor provides that provides similar functionality, but it works across multiple platforms. And we have a sort of basic repository of data model, and we're going to persist the data locally in the database using SQLDelight. Okay, so let's start some coding. Okay, so trying to get my notes here, sorry. So what we are going to do today is, we're going to start, I think it was Brian Garner described sessions like this, I think, as a sort of cookery show, where we have some stuff prepared earlier and some stuff we're going to make fresh. And given the time, obviously, we have, in a similar vein, we're going to start with a pre-existing empty project, more or less an empty project. And it's a good sort of segue to another point, I guess, is that, if you're looking at Kotlin Multiplatform for the first time, strongly recommend you take an existing project. People's Space is one example. It takes a very minimal approach, as I keep saying. Certainly useful, I think, for somebody exploring Kotlin Multiplatform for the first time. If you want getting beyond that, then, TouchLab I mentioned TouchLab before, they have this very nice CampKit project, which takes a more robust approach to things like error handling, coroutine scope management, and things like that. And the other thing to mention at this point, I guess, is that I'm going to make use of Android Studio Live templates and Xcode code snippets, so you don't have to sort of watch me mistype a lot of code. So this is our basic project here. Just to mention a few things, we have a common module, and this is going to be the common code that we share on Android and iOS. And what will happen under the hood then, this is the way this is built, it uses this Kotlin Multiplatform plugin. And it allows you to define various targets, Android and iOS, for example, in this case. And by defining those targets, what it will do is it will automatically build the appropriate artifact then for the platform it's on. When it's being built as part of an Android application, it's going to build a jar file, which is consumed by the Android app. On iOS, then it's going to produce a framework then. And under the hood here as well, we're using this CocoaPods plugin, which sort of provides the plumbing basically such that when we go to Xcode and we make changes, or we make changes to the common code and we do a build in Xcode, then that automatically invokes, using Gradle, invokes the building of this module with the appropriate target and generates the framework that gets pulled in. The other thing to mention is that we'll see that there's a number of source sets or source in this module, and the idea is the main one is sort of the common one here, and the idea is that this is hopefully where the majority of your code is going to be. This is where the pure platform independent code resides, but invariably there's going to be areas where you need to provide a platform specific implementation, and we're going to be using SQLDelight, and that's one good example where the way we create the database is platform specific. So we'll see, for example, we'll use this expect actual, notation or capability that Kotlin Multiplatform provides, where we can, in our common code, we can expect a certain method to exist, and then in our platform specific source, we can provide an implementation for that. So this is a nice capability that exists as well. Okay, so we're going to basically in this sort of session today, we're going to write a people in space API, a small class that encapsulates our interaction with this endpoint here. And this is the example of JSON we're getting back. We're going to add a very basic repository class that wraps around that. Starting off, it's just going to wrap around that class, and then as we build it out, then we'll add persistence as well. And in the case of the Android, we're going to have a view model. We're sort of using standard Android architecture components, and we're going to have an activity that encapsulates our Jetpack Compose code. And then we're going to go over to iOS and do something very similar, build out a sort of basic view model on iOS, and then add SwiftUI code as well that maps very. And this is the other thing, I suppose there's a couple of different, aims for this talk. As I mentioned, I do think this is a very compelling combination together, declarative UI frameworks with Kotlin Multiplatform. But then, the commonalities exist on a number of levels. Swift and Kotlin are very similar to each other, very easy to read Swift if you know Kotlin and vice versa. And we'll see hopefully with the SwiftUI and Compose just how similar they are. Slightly different syntax, approaches, but fundamentally, different syntax and different sort of keywords. But fundamentally, the approach is the same. And I think, this is a really kind of exciting aspect of where we're coming to, in the industry in terms of having this convergence, as I mentioned, on the use of declarative UI frameworks. Okay, so as I said, I'm using live templates quite a bit here. So what we're going to start off with is add a couple of data classes. These data classes map to the JSON we're getting back from our endpoint. And we're using another library called Kotlinx Serialization, which is another JetBrains multi-platform library. And this provides, again, if you're an Android developer, you may be familiar with something like JSON or Mushy. And this provides something similar to that, but that works in multi-platform code. So having added those data classes now, we're going to add in a class which represents our interaction with the endpoint. We're going to add in a URL, which is what we're going to, our sort of base URL. And we're going to use, I mentioned we're going to use Ktor. So we're going to use Ktor's HTTP client object. And this is going to be what we use then to make those requests. And, in fitting with sort of the approach Ktor takes in general, it uses this DSL type approach. So we're going to install a feature, which is JSON feature that we're going to tell it we're going to use the Kotlinx serializer. And we're obviously going to use a logger as well. And we'll see that's kind of useful, it's useful when we run different platforms that we'll see. We get some level of feedback, in terms of that the APIs are being made and they're getting back response. And again, for the purposes of this, we're going to add just a simple method for now, which is fetch people. And this is going to use that client instance to make a request, a GET request, to the base URL /astros.json, returning back an Astro result, which up here we'll have seen is a data class which has a list of people. And when we say list of people, I guess in this context, it's a list of assignments, which is basically the assignment between an astronaut and the craft that they're on. So having done that, we can now move on to our repository. And one thing to note here is that we're using Coin dependency injection. Coin is a dependency injection framework if you're not familiar with it, but it works in a multi-platform environment. So we're able to sort of define our dependencies in such a way that we can share them across both, for example, the Android and the shared code. And having added that, then we can simply add in our API request. So this is, as I said, I'm probably overusing this. This is our sort of basic method, and the repository, the APIs from our repository. This is the surface area that we're exposing to our clients. This is what our iOS client is going to call, and what our Android client is going to call. And we're making use, just to mention, we're making use of a Kotlin 1.4 feature here now, where we can now call suspend functions directly from Objective-C and Swift. Now that does come with some caveats, and it's probably outside the scope of sort of the initial part of this talk, but certainly, if folks are interested, and maybe ask a question at the end, and we can kind of talk about that a little bit more. But it's certainly convenient starting off to have that capability, I think. So having added, so we've made the sort of initial changes to our shared code. So now we're going to start making changes to our view model on Android, and we're using standard Android architecture components here. We're using an Android view model. Again, we're using Coin to inject the people in space repository, and this is the class coming from our shared code. Other thing to note is that we're using stateflow instead of live data. I think there's a talk tomorrow possibly, I think, that goes into a lot of detail stateflow, but it's another interesting development, I guess. And even though we're not using in this context here, among other things, the advantage of stateflow is that we can use it in Kotlin Multiplatform code as well. But having an Android view model like we have here, we have this implicit view model scope then, which is lifecycle aware scope, and that means that we can then, for example, call suspend functions. And we can call our fetch people methods that we added to our repository, and then we set the value in the mutable, the stateflow value that we have here, and then any client of this view model, in our case, it's going to be the compose code. Then that's observing that will obviously get updated then when that changes. And I just mentioned, we're starting here with calling a suspend function, a sort of a single one-shot call like this. Once we add the persistence code, then we'll move to something that actually more reflects updates or changes as they occur. So that's our view model. We're now going to add our Jetpack Compose code. So the idea here is, we're going to show our application in this case here is a list of the people in space, and for each row in that list, in that table, we're going to show the astronaut and the craft that they're on. So this is again, if you haven't seen Jetpack Compose code before, this is how we represent the UI now in Compose. We have this idea of composable functions, standard Android or standard Kotlin functions that have this composable notation. And hopefully you'll see, how readable this is. I mean, we don't have any external layout files in this. This fully encapsulates, the UI for that row in the list. We have the concept of rows, columns, texts, modifiers where we can set paddings and alignment, and styles where we can apply, things like the typography in this case here. Now, having added that, we're going to add something that represents our screen as a whole. And there's a little bit more coming into play here, but just to mention a couple of things. Again, we have this concept of scaffold, which is sort of a composed construct that represents something that represents the screen as a whole. So we have the top bar, we have body, and we could, for example, have a bottom navigation defined here. The top app bar is simply going to show the title, people in space. And then in our body content, we're using this lazy column 4. And this is, I guess, a comparison that you'll often see when people are talking about, and people started using Jetpack Compose, and they start using something like lazy column 4. And the comparison would be with current Android development, UI development, where you would use a recycler view, where you'd have external, you'd have XML layout, you'd have a view adapter, view holders, and so forth. With Compose, we simply have this lazy column 4. We iterate over all the people. We'll talk about where that value is coming from in a moment. And then for each element in that list, we invoke this existing person view composable function that we added a little while ago. So this is what you end up in effect. You end up with sort of this hierarchy of composable functions that are invoked. And just to mention, I guess, in terms of state, you saw that we added this people. We were updating this people in space from the view model. Jetpack Compose comes with a number of extension functions. In this case here, we're using collect_state. And that basically converts into the idea of a state that Compose can work with. And the key idea, as I mentioned before, is that any change in state then causes this recomposition. It's optimized re-rendering of the UI. So having added that, we can now, so this is our sort of standard activity here, the standard on create, but now we're using another extension function from Compose, which is this set content, where instead of where we may have previously set layout file to use, we can now invoke the main layout directly. Okay, and let's run this. And just the fact that, hopefully the fact that it's building shows you that it's a real demo. So we're, as I said, we're going to run this, show hopefully it running on Android. We'll switch over to iOS, do something very similar there, and then we'll come back and we'll make some more changes. We'll sort of build out the UI a little bit more, and then we'll add some persistence as well. Okay, and there's our list of people in space. As I said, it's a little bit longer than it was yesterday. Okay, so that's our Android client. We're now going to move over to iOS. And on iOS, we're going to add a view model. And you know, if you scratch below the surface, what you see here is actually quite similar to our Android view model. We're writing this obviously in Swift. We're using combine. We have this concept of observable object and published. But we're using, for example, if you look at the people in space repository and assignments, these are the same classes that are coming from our shared Kotlin multi-platform code. And you know, we're calling that fetch people method here. And this is where some of that, I mentioned in Kotlin 1.4 that now you can call suspend functions directly. So we're doing that in this case, but but there is a wrapper created under the hood, which maps then from the invocation of the suspend function in the shared code to this Swift method, such that, for example, if an exception occurs, that automatically maps to an error here. And then if the result is successful, then we set this people value. And this is very similar to setting that sort of people in space state flow that we had in our Android view model, setting something that's observable in the UI. And the UI in this case then is we're going to add a person view just like we added in Compose. Obviously, it's a struct in Swift as opposed to a composable a Kotlin function that we were using Compose. But again, hopefully you see that the constructs are very similar. Instead of row and column, we have H stack and V stack. We have text elements. The approach to modifiers, alignment, styling is a little bit different, but it is fundamentally the same approach. And then if we add, we're going to add sort of again the same idea as we did with Compose. We're going to add something that represents the screen as a whole. And where we had that lazy column for in SwiftUI, we have list. And likewise, we're just going to iterate over all the element people coming back from the view model. And we're going to invoke this person view. So we run this. And, you know, I guess to mention as well, you know, what's happening under the hood here is that it's actually it's kicking off a Gradle build basically of our common module with the iOS target, and it will only have to do this. You know, I guess if you think of sort of what the workflow might be in a sort of typical Kotlin multi-platform project, hopefully the shared code isn't changing quite as often as the UI. So this kind of longer build time should only happen any time that the shared code changes. And there we have our equally sophisticated UI that we have had on Android. Okay, so next stage is we'd like to sort of enhance the UI a little bit. You know, one of the for example, one general requirement for UI like this would be to show obviously the image of the astronaut beside them. So what we're going to do is we're going to add in a method to the repository to fetch the image. Now, so I don't have an endpoint, or the endpoint I'm using doesn't give me the URLs for the astronauts, so it's a little bit hacky for now, where I'm sort of maintaining a list of URLs within the shared code. But I think it's a good segue to a point here. You know, as this approach that we are taking, we're doing it in one place. We're doing it in the shared code, and if and when we have a better way of doing this, then that shared code can be updated, and the UI code, the client code, doesn't need to change. And so this get person image is a method that we're going to invoke from our Android and iOS code. So if we go, for example, to our view model, and we add a method into our view model to get the person image, and then in our Compose code, if the observant of you may have noticed this commented out line, we're going to uncomment this out, which is we're going to start using the URL coming back from the view model, and now we're going to add in we're going to use a third-party library called Coil to render the image using the URL. If we run that, and we get the images for the astronauts, and we get to see the 4 cool new SpaceX suits that the 4 astronauts that went up yesterday used. And then likewise on iOS, we're going to update our view model here. in a very similar manner. We're calling, again, just a key thing to emphasize here is that we're calling this get person image, which is a method that we added to our common shared code into the repository that we're invoking here from Swift. And in our SwiftUI code now, in a very similar manner, we're going to comment out this, we're going to comment in, I guess, the retrieval of this URL. And as I said, again, in a very similar manner to the way we added the image, coil image to our compose code, we're going to do something similar here. We're using a wrapper that I'm using here, SwiftUI wrapper that renders an image based on a URL. And the other thing to note as that's loading there is that, forgot to point out before, is that we can see the Ktor HTTP client logs here from the request that was being made. And now we have our images here as well. So again, you know, I think it was an interesting example in the sense that even though this isn't, you know, if we go back to our repository, you know, it's, as I said, somewhat hacky approach to sort of getting these URLs, having this sort of static list of URLs, but at least we're doing it in one place here. And having done that and exposed an API method to access that, then our client code can use that, and this code can then obviously get updated if and when we have a better approach to getting that information. So right now, you know, what we have, we've just a recap. You know, we added in this basic class representing our interaction with our remote API endpoint using Ktor, single Ktor API request here. Like I mentioned, if you look at the repo from GitHub, there's also we also have another interaction here with to get the position of the International Space Station as well. That's in that code. And our repository then right now is a very simple wrapper around that. We added a method to, you know, wrap around the call through the API class and also one for the image. Our view model then is calling into the shared code to get that data, updating state flow, and then our compose code then obviously then is rendering that information then in Jetpack Compose. But as I said, there's a sort of a, you know, significant issue here, I suppose, in the sense that in invoking the suspend function like we're doing here, it's a sort of one-shot request, and any changes then obviously aren't reflected. So what we're going to do is make some changes to our repository. And what we're using for our interaction with our database is a excuse me, is a multi-platform library called SQLDelight. And with SQLDelight, you define your sort of as the name sort of suggests, I guess, SQL-like queries here. And there's a plugin then. There's a Gradle plugin then which will automatically generate queries then associated with these. So what we're going to add into our repository. Again, this is where some of the pre-prepared code comes in. We're going to add it, and I'll explain it obviously as after I add it in. We're going to change the code around a little bit so that on startup, we're going to fetch the people from the endpoint, but now we're going to store it in the database. And we're using this people in space queries, which is a class that was generated from those queries that I showed in the SQ file. And with that available, you know, we have this capability now where we can store data, you know, in the case of Android and iOS, obviously like in a SQL-like database, but using the same code. And just to point out one other thing, the way we're actually creating the DB then is using this. This is where I touched on this expect actual capability that Kotlin Multiplatform supports. So we have a create DB method here that we expect in our common code. And then in our actual, for example, if we look at the iOS source tree, we have the actual implementation of this. And this is where, in the case of iOS, when this code is running on iOS, this is the create DB method that will be invoked. And then the other thing to note then is that we have a method then that will return the data as a Kotlin flow, which means then that we can go into our view model, and instead of having this one-shot request here, we can collect the data. And now, as that data changes in the database, now we're getting closer to I guess what is obviously a significantly more common use case here, where maybe we get data from a remote endpoint through how that data gets updated. Of course, there's another discussion in terms of whether we poll or we get a WebSocket update. That data is typically stored in a local database, and then we drive our UI from the database, as we're doing in this case here. So if we run this, So nothing obviously will have changed in the UI, but if I open up Database Inspector here, and for example, make a change here, if I add in, let's see if I could become an astronaut for a brief few seconds, you see the UI got updated then with that. That's obviously reflecting the fact that this data is now coming from the database. And you see, for example, if I rerun the application again, where we're obviously going to refetch the data again, you'll see it show what's on the database initially. And then obviously it will update then with the data it gets back from the endpoint. And there we go. So this very sort of what would you call it? Sort of whirlwind tour through sort of an Android or a Kotlin Multiplatform project and sort of the moving parts to it. As I said, this is based on People in Space repo. You're very welcome to obviously pull that down and try it out. As I mentioned, it does run on a number of other platforms. And just sort of to mention briefly, there's just to give you a quick demonstration of a couple of the other clients that are supported. So this is the Mac OS client. And again, this is using the same shared multi-platform code. In this case here, we have additional endpoint where we're getting the position of the International Space Station, and that updates periodically polls for that. There's a web client, as I mentioned, and as of a few weeks ago, at least, or at most rather, I guess, we now have a Jetpack Compose for desktop client as well. So again, this is, I think this is fascinating on a number of levels. I mean, I talked about the fact that in the iOS world, or in the Apple world, I guess rather, we have SwiftUI multi-platform, as it's called, in terms of the ability to have a single code base, allowing you to develop UI, across multiple Apple clients. Now we're starting to see that same capability with Compose, with Jetpack Compose, where we can. So this is using, not only is this using the same common shared code in terms of the Kotlin multi-platform, but it's also reusing Jetpack Compose code. So, this list here basically is being driven from the same Compose code. Obviously, with the greater sort of screen real estate we have with the desktop now, sort of how we approach, the details and what we show on different screens obviously changes. So that was it. I think I'm hopefully doing okay for time. I guess if folks have any questions. Okay. Interesting. So the first question, I guess, is understandably a very common question that's asked. How is Kotlin Multiplatform better than Flutter? And I'd rephrase it slightly differently. I'd say it's different than Flutter in the sense that, I was kind of probably overemphasizing it during the talk, but Kotlin Multiplatform is primarily focused on shared non-UI logic. Flutter obviously is kind of an approach, as is the case of, say, React Native and other approaches. This is where you got into sort of cross-platform versus multi-platform and some sort of subtleties, I suppose, in the differences between those. But Kotlin Multiplatform sort of purposely takes this approach of targeting non-UI code, shared repository, perhaps your use case layer, or there's quite a few examples that maybe take view models, or part of the view model, or a presenter, or whatever sort of pattern you're using, and push that into shared code. But then I think the key benefit then of Kotlin Multiplatform in that case is that you're able to use the best in breed sort of tools and technologies and frameworks to develop your native UI in a sort of compelling UI. And ultimately what we want to do on mobile is we want to create a compelling user experience. And typically, at least, this is, I guess, a somewhat controversial point, but at least in my opinion, the way to do that is using sort of native tools and technologies to do that. The other thing I suppose to mention about that is, where, I said Kotlin Multiplatform is targeting the shared code. We're seeing some sort of now with sort of Declarative UI frameworks, and I suppose this is the other thing. I guess to the credit of Flutter, I suppose Flutter has probably contributed to sort of popularizing the approach of Declarative UI. I think there was a question whether to what extent Flutter inspired Compose. I think it was more probably from the React side of things where that came from. But at least that's a common approach, and I think you'll see that. For example, I see on Twitter a lot of people who are sort of Flutter users starting out to use Compose and sort of seeing the similarity in the approach and seeing potentially something that looks interesting. So the next one, can multi-platform be used to make libraries can be accessed? Yes, absolutely. So there's a talk, I think, later today by Russell Wolf, I think it is, from Touch Labs, and he has developed a number of libraries, actually. His the multi-platform settings and a few other ones. So yeah, absolutely. And you know, if you're on Kotlin Lang, for example, you know, you see a lot of questions there about people sort of looking to see what the moving parts are, the mechanics of doing that are. But yeah, it's certainly possible. What considerations to take when supporting web, tvOS, custom binaries for different system architectures? So I mentioned that in the shared code we have a, you know, we're using Gradle. We have a build.gradle file, build.gradle KTS file, for example, and we're using this Kotlin Multiplatform project. So that supports targeting a range of platforms. We saw today with Android and iOS, obviously. But the example, for example, the code in the repo, for example, has a contribution. The guy called Neil Sanch contributed a watchOS implementation. So you know, with these, and you know, when we talk about Kotlin multi-platform, sort of again, if you go under the hood a little bit, we talk about sort of Kotlin native and Kotlin JS and Kotlin JVM, for example. Kotlin native is the sort of the aspect of that that's used on iOS platforms, for example, and also on Windows. So there's the capability there, I guess, the short answer, to sort of target and create the artifacts that you need for your platform. How does the common Kotlin code from Studio end up in Xcode? Can I edit in Xcode? Okay, so I think this is definitely an emerging area. TouchLab have a plugin. I'm not too sure how actively it's up to date. I haven't used it in a while. They have a plugin which you can, where you can browse your Kotlin code within Xcode. And because of the mechanics in terms of, you know, the plumbing of the CocoaPods plugin, for example, if you're using that, when you make a change there and you hit run within Xcode, that's automatically going to build the multi-platform module for you. So I see you're using Coin on the shared code base. How does that work on iOS? So the code base, this is, I suppose, a caveat, I suppose, or not a caveat, but I suppose just a qualification. So I'm using Coin in the shared code, and I'm also using it on Android. I'm not using it on iOS right now. But having said that, I mentioned the CampKit project from Touch Labs, and they actually wire up from their and expose sort of APIs from the common code to their Swift code, so that they can kind of manage the dependencies all the way from the sort of iOS layer all the way down. In the case of the example today, we're primarily using the shared code we're primarily setting up the dependencies in the shared code, but then obviously, you know, we're able to take advantage of that a little bit more easily on Android side right now. Can we use it in production now? So that's obviously a very common question. I think it's defined as alpha right now. It is being used in production, is one way of answering it. I suppose in the same way that I guess some people are starting to use Compose in production. Compose is sort of alpha level right now. It has matured significantly over the last year or so. That's the other thing to mention. I mentioned about the sort of Kotlin multi-platform mobile, the definitely significantly more focus from JetBrains on Kotlin multi-platform. They're much more invested in obviously making this a success, and you get companies like TouchLab obviously helping significantly to push that and contribute to that as well. The other way I'd answer that, I guess, is that a key benefit of the approach of Kotlin multi-platform is that you can use it for as little as much of the shared code as you want. So I think that's what, and you see people doing that. For example, okay, they're just putting their toes in the water a little bit, putting in, defining their some small part of their shared code, maybe a data model like I mentioned, or access to a remote endpoint, and putting it in for that, getting the structures, the process in place, checking it out, and then kind of building up from that. And I think that's, like I keep saying, I guess it's a key strength and a really important strength of Kotlin multi-platform that allows that. Can Kotlin multi-platform have access to shared platform-related APIs? Yes. So there's and definitely recommend Russell Wolf's talk, because I think he'll probably cover this in a little bit more detail, because this is the sort of things that he, in his, for example, his multi-platform settings library that he has in Kotlin multi-platform, it will use native iOS preferences, for example, for the settings when it's being used on iOS, and obviously we'll use sort of Android shared preferences when it's being used on Android. How does the repo returning flow work with iOS? No, it's a good point. I was wondering if someone would spot that gap in the talk. I kind of skirted over that a little bit, but the repo, just to say that what we have what's in the repository does address that in the sense that you can't. I mentioned that Kotlin 1.4 adds the capability to add call to spend functions directly from iOS, from Swift and Objective-C. There's a gap there, obviously, with Flow. So what you end up having to do, and to be honest, I think a lot of people are using the same approach even for calling suspend functions, for example, is you end up with kind of a custom wrapper, and you pass sort of lambdas or closures into the shared code, and then call that back. And I keep mentioning you should get some payment from him for all the mentions, but I keep mentioning Russell. But Russell also wrote an article on a wrapper that they wrote in such labs for Flow, for example, where, again, you have to do some kind of mapping. And the mapping, not just in terms of, I guess, the callbacks that you need to pass and getting those invoked as data is changed, but how you manage coroutine scope, I think. And this is an area I hope will evolve and will get, the addition of being able to call suspend functions directly, it was a nice improvement in Kotlin 1.4, but I hope that will be something that will just continue to be developed, that capability, so it will become cleaner and easier to address some of these cases. How fast is the adoption of new iOS versions? Yeah, and that's actually a really good point as well, in the sense that because Kotlin Multiplatform is targeting non-UI shared code, there isn't that same dependency, and this is the other thing, if we compare with other approaches, somebody mentioned Flutter, for example, and other approaches where maybe you're creating something that is used sort of across the full stack. Because Kotlin Multiplatform is targeting non-UI code, you're free to use the latest. I have an example, for example, in one of the branches in one of the repos where when the new widget capability came out on iOS, where I put a sort of widget front end onto the same shared code, and was able to do that, using the latest beta of Xcode that was available, that provide that capability. So that's definitely a big advantage to this approach, I think. Can we have the same UI changes and deeper changes? Yes, absolutely. Yeah, and that goes back to sort of, I guess, that gap, I suppose, in the demonstration that I didn't show, but that would be shown. For example, if you take the data from the repository, that the DB data changes would be reflected in iOS as well, because the code in the repository is passing any data that it's collecting, any updates it's collecting through the sort of invocation of the method the flow method. Back through a callback to the Swift code. I'm not familiar with Xamarin that much, to be honest, so I can't really answer that. Can you have only one module? I believe I've only really used Kotlin. I've only really used Kotlin Multiplatform with single module, but I know it's a topic that comes up quite a lot, and I'm pretty sure there's been a number of developments recently that have made that possible. That would be also maybe a good question for some of the TouchLab folks who are talking as well. Are existing third-party SDKs compatible with Kotlin Multiplatform, or will they need to create new SDKs? I guess it depends on what you define. I suppose there's an increasing amount, I guess, of third-party libraries being developed that run in Kotlin Multiplatform. Obviously SQLDelight. There's ones from JetBrains, obviously the likes of Ktor and Kotlinx Serialization, for example. Then there's third-party ones like SQLDelight, and there's an increasing number of ones. There's ones for a logging framework, for example, or I mentioned the multi-platform settings one. But yeah, there's you can kind of Google the link probably. I can see if I can, or hit me on Twitter and I can dig it up for you. But there's a nice link somewhere that I think I can't remember who they are that they maintain this GitHub page basically with the list of third-party libraries that can run in Kotlin Multiplatform. That was it.